First, looking back at the datasheet, you can see that for the STM8 microcontroller series, the usable memory capacity of the EEPROM, which stands for Electrically Erasable Programmable Read-Only Memory, is 640 bytes. In addition to this, we can use these 640 bytes. In your makefile configuration file, you need to add in the original library file. However, I forgot earlier on to mention specifically that it's necessary also to incorporate into it the STM8 flash library as well. However, if you've been following along closely up until now, then it should already be added there automatically without issue. Next step involves going over into main code section, where please do remember adding flash component, while simultaneously I'll personally take care of including one, maybe even two macro constants myself too. First among them being none other than our very own designated starting point, known simply enough as EEPROM base address, which serves essentially here acting almost akin towards becoming initial reference marker from whenceforth onward lies entire range encompassing all available user accessible portions within said device's internal storage space. Next, I very carefully entered exactly 640, with precision as specified in the datasheet. To begin with, you need to set the flash. Programming. Time, which is a crucial step in the process. This involves configuring the time settings to ensure that the flash memory is programmed correctly and efficiently. After setting the flash, programming. Time. I have proceeded to unlock the EEPROM. This step is essential because it allows us to access and modify the data stored in the EEPROM. However, in this particular instance, we will not be utilizing the lock feature. It's important to note that when you proceed with actual programming later on, it is advisable to unlock the EEPROM in this manner and then lock it again after the programming is complete. This ensures the security and integrity of the data. If you decide to run this process again, the first step should be to attempt erasing the EEPROM. Erasing the EEPROM is a critical step that prepares the memory for new data by removing any existing data. This can be done by following a series of steps that ensure the EEPROM is completely cleared and ready for new programming. By understanding and following these steps, you can ensure that the EEPROM is properly managed and that the data is secure and accurate. Let's arbitrarily call this state clear for simplicity. This term will help us in our discussion. Just like in the Arduino example, we will proceed once the listen. Firmware is complete. It's crucial to understand that the value is 640, and since 1 byte cannot represent this number, we must use 16 bits to write the email. This ensures we handle the data size accurately. Using 16 bits provides the necessary capacity to accommodate 640, maintaining data integrity and system functionality. This method is essential for our project's success, aligning with our technical requirements and specifications. And there is also a command called erase byte. So you set the base address to truss I above, and there is a command that waits until all of this operation is completed. The flash memtype data simply initializes all those memory areas to 0. Given the current situation, there is absolutely no necessity to proceed with clearing this particular item or task. Therefore, I have made the decision to go ahead and erase it instead. This approach seems more efficient and appropriate under the circumstances, ensuring that we maintain focus on more pressing matters at hand. First, I will proceed with the process of executing the make clean command, followed by the make command. I apologize for any inconvenience this may cause. After completing these steps, I will conduct a thorough check once more using the CoolTerm application to ensure everything is functioning correctly. I have successfully established a connection to CoolTerm, and as a final step, I will press the reset button 1 time to confirm the setup is properly initialized and ready for operation. Then the reset EEPROM appears, followed by done. Right now, we are initializing all 640 bytes of memory in the EEPROM to 0. Let's simply go back to the code and just try writing and reading values at a specific address in the EEPROM. The process of clearing continues, followed by the operation of flash RAM, ensuring all steps are completed. First, I will write based on the base address. Write this down beforehand. In this process, we begin by initializing two integer variables. The first variable, which we will refer to as int a, is assigned a value of 3. This means that a will hold the integer value of 3 throughout the operation unless modified. The second variable, int b, is initialized with a value of 0, indicating that it currently holds no value or a null equivalent in this context. Our next step involves inputting the value of a into a specific location, known as the base address. This is a crucial step as it sets the stage for subsequent operations. Once the value is inputted, we must pause and wait within a designated area called the flash memtype data. This waiting period is essential to ensure that the first operation is fully completed before proceeding. After confirming the completion of the initial operation, we move on to the next phase. This involves reading data from a specific location referred to as the flash read write at the on address. The data retrieved from this location is then stored in the variable b. This step is critical as it transfers the result of the operation into b, allowing us to utilize this data in future processes. Finally, I will construct this segment to verify its functionality within the broader system, specifically in section B. This verification step is vital to ensure that all components are working harmoniously and as intended. Right now, I will press the reset button on CoolTerm. If I press it, it shows 3. Right now, the variable a contains 3, and it has been stored in the byte at the base address in the EEPROM, and then wait for this. I waited for this, and then after reading it, even if I do it like this, here, it has now been saved to the EEPROM, so comment it out. After commenting out the line above, if you run make flash again, you will certainly be able to verify and confirm that it is an important step in this process. Indeed, confirming securely and permanently within memory itself. So one thing worth noting for those who have transitioned from platforms like Arduino side of things, EEPROM addresses start from 0, 0, but here we begin at hex address 4000, 4000. According to our datasheet documentation provided by manufacturers themselves, it's set specifically at 640, 640, so please ensure checking thoroughly whether part number being used matches exactly 640 before initializing accordingly. Then proceed further utilizing it effectively. As I mentioned earlier during discussion today, I've just demonstrated simple method unlocking usage capabilities, yet later advisable employing lock commands securing end results achieved thus far. In current session, explain controlling EEPROM via S108 microcontroller unit setup configuration settings. Applied successfully throughout demonstration period, conducted live audience participation event held recently concluded moments ago. We'll see next time another exciting topic exploration journey awaits us all together.